Okay. So we have here today with us Professor Salomon from Bar-Ilan University. Professor Salomon did his BSc in psychology in the Amirim program for excellence at the Hebrew University. He then completed his PhD at Tel Aviv University in cognitive neuroscience under the supervision of Professor Dominique Lamy, where he started investigating the neural and cognitive mechanisms of the self together in joint guidance from Professor Rafi Malach, who is joining us now. He then continued to do a postdoc at the École Polytechnique Fédérale de Lausanne in Professor Olaf Blank's lab, working on bodily self-consciousness. He then joined the Gonda Multidisciplinary Brain Research Center at Bar-Ilan University, where he's now faculty, to start up his lab of self and consciousness. His lab investigates the concept of self from multiple perspectives, including bodily, actions, and social aspects. His lab has recently expanded to investigate the sense of reality, for which he was awarded the prestigious ERC grant. These investigations are performed both in neurotypical individuals as well as in abnormal conditions of the mind, using multiple methods as behavior, virtual reality, computational, and neuroimaging techniques in order to study how the brain forms models of self and the world, and how they are modified in clinical conditions and when under the influence of psychoactive substances. His research is often covered by the media. He has multiple collaborations in Israel and in Europe. He published dozens of papers, including in high-profile journals as PNAS, Current Biology, Journal of Neuroscience, and others. And he also published a book chapter about the self. So without further ado, I'd like to welcome you, Roy, to our seminar to hear about your exciting research.
Thank you, Sharon. Thank you very much for that very kind introduction. It always seems a bit unreal when people talk about you like that. Yeah, I'm very happy to be here. I'll start off by sharing my experience of the last 24 hours, which is that Sharon is so effective in promoting this that it went everywhere on Twitter. And then I kind of panicked. I said, oh my God, I only have very preliminary data. It's more proof of concept, and somewhere between having a very kind of intimate meeting with a few people here at Bar-Ilan, it became an international thing. So if you are here to hear the answer about life, the universe, and everything, it's not here, okay? You can sign off quietly now. No judgment will be made. We have very preliminary data on a very, very big and slow science project. So the main thing I'm going to show here is our conceptual and theoretical background and some preliminary data. And I'd be happy to get inputs from you and hear your opinions, because I think this is an interesting topic. Yeah, so that was my kind of a preempting caveat. So let's see what we're going to talk about today. So the first thing we're going to talk about, what is reality? And this is actually quite a bit complex, and we are going to have to talk a little bit about philosophy. I don't know if people are going to be squirmish about that or not, but there's no way we can actually talk about this without addressing at least what philosophy has said about this. I'll then present kind of a model we have about the sense of reality, what it is and how we get around to it. And then in more depth to show the difficulty and how we tried to address the problems of how to study this sense of reality, which is not an easy thing to do empirically, show some preliminary results, and hopefully at the end I'll have time to also kind of tell you a little bit about Wonderland, which is the developmental project in the sense of reality, and how this actually comes about in younger children. So this comes the outline for the talk. I'll try to go for about 40 minutes. I prepared this last night and this morning, so if the animations don't work or if timing doesn't work, it's all on me. Feel free to stop me for questions at any time. So I think this question of what reality is something that really bothers us, okay? I think it bothers all of us. It gets shown in popular science fiction. I think even in an early age, we start to have these kind of questions. And I think there are two parts to this. And I'll tell you first my personal story, how I got to this project, and then something kind of more general. So to me, this project started with the experimentation in psychiatric hospitals. On the sense of self, we work a lot with psychosis patients and schizophrenia patients. And when you're sitting in that experimentation room with these people all day, then they're experiencing things, you're experiencing things. And without someone to kind of arbitrate and say who is right, at the end of the day, there's a bit of a question about whose experience is actually right. And this is something you leave the hospital and you're like, okay, what makes my experience now, seeing and hearing all these things, real? And I get to go home. And the patient, he stays in that hospital and he has experiences which have the same noetic quality, they have the same feeling of being real as what I'm experiencing now. And what makes this different? And this is something that kind of gave me a disturbing feeling. And from that feeling, over several years, I kind of developed this idea that maybe this is something we should actually try to look into, especially since it has huge implications for how we define neurological and psychiatric health. This kind of feeling of knowing what's real and what's not real is a very basic part of this human experience. But when we're not in a room with other people, this often becomes more difficult than we think. So it turns out we very often use other people to know what's actually going on. And the first thing we do when something strange happens is, did you see that? We try to bring in someone else to try to help us through this problem, okay? So how do we know what's real? Okay, this seems like a simple question, but I'll very quickly show you that this is not so simple, okay? So first of all, there's all kinds of real. For instance, when we see this light, we kind of know the light is real and we think this light pole is real. But what about these kind of crowns of light around light? Are they real? I mean, they're real in the sense that we perceive them, but are they real? Could we touch them? Are they real in the same way that the light pole itself is real? Okay. And I think I remember as a child, I used to play around with these kind of rays of light. And I think this is something that says a lot about, because I think the real world is often perceived with a lot of additional stuff. And we'll see how this model of reality also subserves us in normal vision, day-to-day vision, which I think is kind of the topic that we usually talk about here. Rainbows are definitely real. I mean, we all see that. I asked you, did you see that? And yeah, of course I saw that. The rain, we can take a picture, it stays in the picture. But if we try to grab them, we can never grab them. So sure, they're real in an optical kind of way, but they're not real in the same way that table maybe is real to us, right? They're real to only one of our senses, not to other senses. And just to show that reals can be kind of many things, right? So colors are real, kind of, right? They're real if you see them. If they're not real if you don't see them, we know that they may be kind of arbitrary. They're a real experience for us. We use them a lot in the way we define features of objects. But we can also totally accept that some people have no colors, or other species have no sense of color. Okay, so I think color is kind of an easy way to demonstrate what real is, and that it's kind of troublesome to decide. So is this moving? Is this movement real? Okay, there's definitely a problem here because I see it. I really see it. I actually hate this picture. I'm going to remove it for the next talk because it's very disturbing. But but we all know that it's also not real. It's not really moving. Okay, so what's going on here? Okay, you know these floaters. I don't know if you can see in this picture, but often we have, like, within our field of vision, something floating. You can see that kind of these shapes, like these small worms in our field of vision. And these floaters are actually something that actually answer to the qualification of a hallucination, in the sense that they're something I experience, but only I see and no one else can see, and it doesn't exist in the outside world. However, we know that these floaters are actually probably dead cells floating within our eye. So there we have kind of a neurophysical explanation for them. So we don't consider them hallucinations. But when you ask doctors, for instance, if a tinnitus is an hallucination or not, they also get into a quandary. So if you hear something which is no one else hears, if you have a neurological explanation for it, it seems okay. If not, we call it a hallucination. Okay. And of course, this question has been bothering people for a while. This is a kind of a late Renaissance painting from a Flemish artist depicting the cave, Plato's cave, which of course is already an interesting idea, that maybe what we perceive is not what is really there. So this idea dates back to antiquity, and the interest of what is actually out there, I think, is something which has kind of bothered us for a while. And just to say, there's something very interesting about it, the fact that humans can hold these counterfactual thoughts with regarding our perception, our senses, first of all, it pertains a lot to reality, but also to consciousness. So we can perceive things and say, that's not real. And that's an interesting facet of the human consciousness in itself. Okay. And so just for a brief kind of going into philosophy, I think the most basic way we see this, and even though it seems very basic, is what we call naive realism, right? So when I open my eyes in the morning, I see a world, and this world, when I touch it, it also works, and I can get into my car, and I can drive, and I can do many things. Everything kind of seems to work out. So we have occasionally some strange occurrences like this, but these are actually kind of fringe things. They don't happen that often. Usually I get along quite well with naive realism. Clearly, children often believe this. Many important philosophers also kind of believe in this naive realism. We're actually perceiving the world as it is, and our perception reflects this world in a very coherent manner, even in an identical manner. Okay, and I think this is well captured in the idea that seeing is believing. Okay, and even though I'm going to show you other options of how to believe the world, and we're all going to say, yeah, those are more informed. At the end of the day, we all use naive realism all the time. Okay, we use naive realism to how we work on the world. When we wake up in the morning, we don't say, this is a representation. We just get up and wash our hands and brush our teeth and do everything we do based on what we get from our senses. Okay. After naive realism, I think people became slightly more informed, and there was an idea that, okay, the world actually, there's some processing along the way. Okay, so we get to the idea of kind of indirect perception. And here there's an idea that within our brains, within our minds, we actually build a representation of what's out there. And this representation is now what we hold, and we're not seeing the world exactly as it is, but we're seeing some virtual replica of some aspects, all aspects. There's a lot of discussion on what exactly we're experiencing from this world at large. Okay, and I think this is kind of the idea of the allegory of the cave. Okay. Now, our work as scientists, especially vision scientists, is actually to ask a bit more. So I think we're kind of all now, there's some good evidence that this somehow happens in our brain. Damage to specific brain areas will give deficits in what we experience from the world. I'm kind of convinced that it's a good place to go looking for these things. But the how has changed quite a bit over the past few years. So when Sharon and Yulia and I were working for Rafi, we all got this really nice story. Said, okay, from the world, we go to the retina, and then it goes into our brain, and we have these really nice hierarchies and this feed-forward story from small visual fields to large receptive fields, from small features to more complex features. It was a great story for a while. It lasted. And this is kind of an image from Herzog and Clark showing kind of this idea of this feed-forward idea that was quite dominant in the visual world. But something has changed there as well. I think there's something interesting here, and it pertains to reality itself. So we have this problem, okay? And I'll give you a moment to look at this problem, okay? There's something problematic here. I don't know if you can see it well on your screen, but I have a strong sensation that this garbage can is floating in the air, okay? And it's not supposed to float in the air. I know many garbage cans in my experience, they don't float in the air. And yet this one seems to be, I see in photo, it's very strong evidence, it's floating in the air. Now, of course, it's probably not floating in the air. I think if we look, we can see that there's actually something here, which is kind of an oil spill or something, and it gives the sensation of a shadow. And we know something about shadows. And we know something about shadows because somewhere within our minds, we already hold some expectations about how the world works, okay? And this is, of course, the idea of predictive coding and inference, and so seeing the brain as an inference machine. We have many examples showing that we actually base our perception on an interaction of what comes in from the outside world, but also, and to different amounts, on what we know about the world. So these are, of course, all the same size, and this, if we switch it over, we'll see the concave and convex circles being different. And the idea here, and I think this is a very powerful, interesting idea with many different variations, is that in the brain, there is stuff going on that goes in both directions. So we're both getting information from the outside world, but the brain is also sending down signals, which are called priors or expectations, which are built from our experience with the world, to the eye and within the own machinery. And what we're actually getting here is a mixture between what we expect in our experience in the world and what the world is actually sending to us. And I think something which is interesting philosophically here is this leaves us as a quandary as to what is actually out there, right? So if we're constructing this world and we're not just this camera collecting the world as it is, what's actually out there? And this is a big question. Many of us will just say, well, it's kind of like that out there, and maybe we construct color or we do all kinds of simple constructions. There's very interesting work by Donald Hoffman and others that suggest that reality has nothing to do with how we experience it. It's a very nice interface theory, and saying, in the same way that an icon on your computer does not represent the inside of the computer, seeing a red apple doesn't mean that there's a red apple there at all. It's just how our specific system decides to give us an icon of representation. So this gives a big question about what's actually out there, what's in reality. Okay? And the project comes to try to address these issues. Okay? This is the Unreal project. So just some important definitions to make things very clear. And I'm saying that, but it was unclear to me even when I wrote it at the night. So the sense of reality is the process by which the brain judges if perception represents the world. Okay? And of course, we can all already hear that this relates both to things studied under the term metacognition, and clearly has relations to what we call precision or the estimation of noise on our judgment. And I completely agree. I just think it's a specific case of a process that we'll see soon. The model process is a general process, and this is a specific case. Okay? And this is a continuous process. Our brain is always engaged in it. And it has both implicit and explicit effects, and we'll see those later. Okay, and we'll see what the difference is. And since the sense of reality is such a central criterion for neurological and psychiatric health, the definition of neurological and psychiatric health, I thought it would actually be very important for us to have a model of how this happens in the brain and mind. And this is what we want to address in this project, but we have not done it yet, so you can still leave if you just want the bottom line, come back in a few years. Okay, so when we wanted to model phenomenological states to this, we said, okay, what's actually happening? What are the main axes explaining the variance if something is real or not? So the first thing is an axis that we say, how statistically frequent the stimuli is. Okay, so this sounds kind of fluffy, but it's completely not fluffy. So if you would take a record in the visual modality, everything you see during your life, you would have a statistical database saying what is frequent and what is infrequent. If I want to borrow from the matrix, so seeing a spoon like this is something quite frequent, and having a spoon bend in your hand is an uncommon stimuli. So one I've seen many times, and it fits well with what I know about the world. And the second is an experience which is, well, I've never seen it, but except in the movie. Okay. Now the second axis relates to what we do with this information, how we feel about this. And there's something very interesting here. So this is an axis that's sometimes called insight, or this is an axis of how we judge if something is real or unreal. Okay, and we can now map several phenomenological states to these kind of two axes. For instance, our normal cognition or our normal state is here. Most of the stuff we see is quite frequent, right? So we see the same people, the same cups in our office, and it's all how it kind of seems. And we typically judge this to be real. Right? We walk around and we say, okay, this is the real world, and we have no doubts. And that being said, when I prepared this, I thought that actually the last few years have been kind of strange. We've seen many changes in what this kind of normal is. Sometimes it's felt very unreal to us, or at least to me. And if I told you 5 years ago that we'd be wearing masks for 2 years, none of you would believe me. You'd be laughing, right? So I'll put that as a caveat here. Things can change. I think on the other end of the axis, we have psychedelic hallucinations. Psychedelic hallucinations bring in very strange and non-typical stimuli to mind and to the visual modality. And typically, we feel that they're not real, right? So if you retain insight, and most psychedelic compounds usually retain insight, you say, wow, look at all the pretty colors and all strange shapes. But this is not the real world. I'm going through a psychedelic experience and it's going to abate. That's usually the experience. Okay, dreams, okay, can be very strange, but we believe them to be real. Okay. That being said, when I really think about it, and maybe it's my own problem, most of my dreams are actually not that strange, right? They have strange features, but when we actually talked about in the group meeting just now, at least my dreams are typically quite, I never see this kind of, or very rarely see like a fish eating a tiger, jumping over an elephant like the Dali portrayed dream, okay? But while we're in that dream state, this is for us reality, okay? On occasion, we sometimes have lucid dreams that for the same content, all of them would say, wait, this is a dream and this is not real. And some people work on this and they have very nice control over the dreams and they can actually have this insight knowing that this content is not real, but rather a dream state, okay? Imagination can kind of span between more frequent or less frequent. Typically we imagine kind of boring things, but some of us have good imaginations and they invent helicopters during the Renaissance. But if we're healthy, we always know this is not real. So this is imagination. Also has different features. And there's some very, very nice work on that coming out of UCL now from Nadine Serra on this, how we discriminate between reality and imagination and memory. Okay? Psychotic hallucinations, even though they're typically quite benign. So typically people are hearing voices, which is what we kind of hear most of the day anyway. We're not hearing something very crazy. But one of the problems is they don't know that they're not real, okay? And finally, derealization is very, very interesting because it's kind of the opposite. In derealization, everything looks normal, but doesn't feel real. And I don't know if you know, if there's a lot of research saying that during COVID, there's been a huge surge in derealization phenomenon, which is a serious psychiatric complaint. Okay, so we can now map these things, and from them we can actually derive a model of how to do this. So our model is based on a Bayesian model of the world, and the idea is this: that we have what we call a reality prior. We have a prior built upon the knowledge and the expectations we have learned from the world. We have something impinging on our senses, which is the likelihood, and basically what we experience is a combination of the two. And the more distant the prior expectation of the world is and what's coming in from the world, then we have this distance is defined as a prediction error, and the prediction error is kind of looking for a solution. You can either change your expectations, you can roll this up in the hierarchy and ask for a higher level to respond and try to solve this for you, okay? But basically this prior knowledge and experience is meeting something strange here in the world, and we have to somehow perceive and get a response. So are these cars the same size? They don't look the same size to me. But I also have knowledge that this is an illusion, they should be, I've measured this, okay? So while I'm seeing one thing, I can hold the counterfactual idea that they're actually the same size, even though they don't look the same size, okay? It's clear, are there any questions about the model? I'm happy to take questions in the middle as well.
Well, just clarification. You seem to be mainly talking about metacognition when you talk about the reality axis, not something that you intuitively feel that it's unreal or real. Because, you know, for example, visual illusion, I metacognitively, I know that they are not real, but they appear perfectly real to me. So, so you are talking about sort of a intellectual process by which I'm saying, well, it cannot be that I see this dark patch on the thing moving. It's an after image because I looked at the sun, something like that.
Okay, first of all, it's an excellent question. I think what's important is to say here that this is a process that is continuous, right? So I think this is kind of an extension of the same process that we'd see in low-level predictive coding, okay? So if the retina, if the ganglia on the retina are getting something which is very strange for them, some kind of configuration, we'd probably already see that even within very low levels, there's already some prediction error, right? So something is not fitting well. And ideally within this Bayesian model, and this is an important feature, the thing that this process allows us to fight is fight off a lot of noise. So if you think of that kind of like a light spreading or the complexity of what's actually coming into our senses, having priors about what to expect really helps us narrow this down and get a more stable experience of the world. Okay, so if there's something noisy, I don't know, like the light reflecting or a reflection on this picture next to me here, I don't think I'm there because I have expectations about the world and they help me constrain this visual space in a totally implicit manner. If the prediction error is too big to be solved at lower levels, if something really strange happens, so if into your office now walks a pink kangaroo, okay, you can't solve this in V1. Okay, you would probably really have to assess at a higher level what's going on. Is there a pink kangaroo in my office? Have I completely lost it and I have to go see a neurologist? Okay, and you have to decide either to change the world or think that something is wrong with you. So I think it's easy to demonstrate the high-level problems with this, but I think it's a continuous process and it starts off even with the smallest errors. Okay, just you get to feel it when it's quite big.
Okay, thanks.
Roy, I also have a question. I mean, I know you're going into the disorders of the mind, let's say, but I'm thinking of perceptual deficits, even going down to amblyopic vision, but also agnosic vision and people with face blindness or prosopagnosia, whether their axis of realness is the same. I mean, I don't know how you can estimate the magnitude of the realness, but do they perceive the realness in the same way that, let's say, neurotypicals or people without such perceptual disorders do? Because I think this is not where you're taking this, but I think it would be interesting. We can talk about this later to see where they are at on this like XY axis you've proposed. Whether with these perceptual deficits or with the blurriness of the visual inputs, or do they have the same sense of reality as as other people do?
I think that's an excellent question. I think this is actually accounted for in our model in the sense that, and I also have some, not in my own data, but something interesting. So I'd say that someone who has blurry vision would have a very different prior regarding some of the things in the world, right? Okay, so if the world is kind of blurred to you, and if you see, for instance, one thing we do is maybe blur. So if the world is blurry for you and you wear glasses and something, then that's okay for you because maybe you just don't have your glasses. It's part of what you could expect in the world. I used to have very good eyesight and now I can't see anything close up. For me, this feels really strange. Okay, so I've taken upon myself that my eyesight has changed and not the world has become blurry in itself. But I think my prior is kind of changing, and I think this can accommodate people all kinds of deficits. That being said, it's very interesting that people with visual deficits have a tendency towards visual hallucination psychosis. Okay,
you're saying that as a fact because I wasn't. You are saying that.
I am saying it's not something I discovered, but it's well known that like the having visual deficits. Of course, we know, if you have scotoma, it's probably going to fill in with something.
Yeah.
Visual deficits are tightly linked to hallucinations and even to psychotic states. Okay, just saying this kind of a side note to which something is very interesting.
Interesting. Okay.
Okay, so great. Now we have a model, but how do we do this? How can we actually fit an empirical framework to try to test this model? So grabbing people who have hallucinations, that's already kind of a special population. Exactly when they have their hallucinations is quite complex. And we can't quantify these. So we took a different approach. We used what we call virtual hallucinations. So we took VR and we put people in a very high-end VR environment. They kind of walk around, look around, get to feel, they see their hands in this environment, they can move their head. And we get them acclimated to this environment. It's kind of this nice house, and you can see butterflies and all kinds of things happening inside this house. And once they're used to it, we can now start mucking around with different aspects. And all these aspects we decided to choose are things that we've taken from within the phenomenology of hallucinations. For instance, color saturation deficits or extra color are well known in both in psychosis, but also in depression. They say the world seems kind of gray to them. So we can play around with this color saturation. We can add effects like this, like a ripple. Ripple is a very classic psychedelic effect. It's in the psychedelic encyclopedia, where kind of mainly in peripheral vision, things seem to kind of move around. Okay, and being VR, we can do whatever we want. We can make you really big or really small, like Alice in Wonderland. Okay, we can make you way taller than you really are, or way smaller. We can change the laws of nature by mucking around with time or gravity. Okay, so virtual reality allows us a very flexible and empirical, because it's all quantifiable way to actually create virtual hallucinations. And what we're actually doing, we're building the content of hallucinations in a bottom-up way, and we're checking what happens to the brain and mind and the body while we do this. So this is our approach. It's nice, it's strange, it's very complex. And the way we do this experimentally is two things. We do a first experiment in which we assess psychophysical thresholds within each person. Because one of our biggest challenges is how can you compare gravity to saturation? Okay? So what we do is we do many, very time-consuming psychophysical staircases, I'll show you in a moment, for many different types of variations or conflicts we put into this world. And after we have for each person the same psychophysical thresholds, we now use these psychophysical thresholds as the levels of manipulation in a new experiment in which they ask them, they see an environment, they ask, well, was this unreal or unreal to you? And now we stopped using unreal because in Hebrew doesn't work well. Is this normal or strange? Okay. And people have to rate how normal or strange. But given that we did psychophysics and now we have the same levels, they should be comparable between different people, between different levels, and between different types of manipulations. Okay. How does this work in reality? So you see two pictures and we ask you same or different, and then we change the difference based on your response. So it's an adaptive staircase. And you can see here for ripple that people kind of get, and we can estimate the just noticeable difference. Okay. It's not been easy to do psychophysics because it's not classical psychophysics on a very low level aspect, which is very clear. Some of these are kind of more complex. But we get for each one a fit, and we stick with it until we get fits that we like for each subject that we can assess the psychophysics. You can see here over several subjects, we're getting quite good fits, but we do psychophysics for all of these. Okay, so we have, this is about 2 hours of experimentation just to get the fits right. Okay, and we can see that for many of these, people actually converge on kind of stable psychophysical levels, meaning that between subjects, you know, there's some kind of, for how, when you start noticing when we made you too big, there's kind of a similar level for many subjects. It seems to converge. It's not completely random for each person. We also know it's not random because when we look at the correlations between these, we see that they're correlated. So people are not just guessing randomly. We see that the J&Ds across different aspects of reality that we muck around with are usually very significantly correlated. And interestingly, in a previous paper, we've already seen that your sensitivity, especially to kind of deviations within the domain of self, like delays on your movement or changes in your point of view, are correlated with psychosis tendencies in the healthy population. So if you're not sensitive to how much we've changed you, okay, made you bigger, made you smaller, you're also going to have a higher score in the PQV and also on the CAPS. Okay, so there's already something within the healthy population linking these kind of thresholds to mental health. And then in Unreal, which is the second part of the experiment, we basically show you the environment and we ask you to rate, so we can make you bigger or smaller. And for each time, you kind of do some task in the environment and we ask you to rate how real or unreal it felt to you. Okay, so here we're really taking a subjective estimation of what you feel. And before I show you the results, I'll show you 3 kinds of predictions we have for this. Okay, so these are the levels here, and remember that the same levels across all subjects and all, because we use J&Ds. And this is reality rating. So up here, we have 3 kinds of things that we thought would happen. One is we could have this kind of response. So for 0, people give a high reality rating. And then here, you have to think that this is kind of the J&D, just a noticeable difference. So when it becomes liminal, when it becomes, people can see it, they say, it's not real. So this is one kind of thing saying, okay, when it's explicit, I feel that it's not real. Another response can be a more linear type response. So even when it's subliminal, at levels that you should not be noticing it, you're already getting some kind of gut feeling or some estimation that maybe something is going on. Okay? And of course, we can also have some things which are completely unaffected. In fact, our expectation for color saturation is that it's going to be rather flat because we know that we change around. You know, when we change lights, we put on sunglasses, our whole spectrum changes quite a bit. So we should have a very wide prior for color. And changing around color should not cause us to feel very strange. If it would, then whenever we put on our sunglasses, we'd feel freaked out, and we don't. Okay. So what we got, and these are very preliminary findings, you can see that we have high ratings for the low levels across everyone. So this means that people can kind of get into this premise. We were worried that people would go in VR and say, well, none of this is real, it's virtual reality, okay? But across different types of manipulations, we indeed get different shapes and different slopes, okay? So we can see, for instance, that for a ripple and for color changes, only when we get to a very high level, when it's very salient, so this is at like 99% of the psychophysical fit, then people say, okay, something's wrong here. However, when time goes too slow or too fast, even across the mid levels, you can already see that people even though they're probably not noticing this explicitly, they already have some feeling that something is wrong in this environment. Okay, and this is interesting to us because we know from psychosis and from many other psychiatric conditions that before the onset of psychosis, people have a prodromal period in which they have this kind of feeling of uncanniness. So they can't say what's wrong, but they feel something is already wrong. And I think this is what we're trying to aim at, kind of with these low levels, which are subliminal levels of alteration. But very preliminary data. Yeah.
Can I ask you what you're saying, slow and fast? So are these you said that there were butterflies and stuff like that. So are these aspects of the scene that are time-wise? Because otherwise everything is static, isn't it?
Yeah, so we actually going into this project and trying to make something which manipulates time. So it turns out that like the physicists that say time doesn't exist are actually quite correct. Only thing that exists is motion. So when you want to do time, you have to find something with motion and reverse it. And that also depends on expectations. So we have butterflies kind of floating around, moving their wings, but we also have something which is falling, and the rate of its fall can be manipulated.
Wow.
Yeah, laws of nature, yeah, they're really difficult to muck with, right? Especially time. Time is especially
Nice.
Gravity is easy, but time is difficult.
Yeah.
Okay,
lovely.
Again, being very preliminary data, I wouldn't put too much stock in any of this. Don't want to overinterpret it. We'll wait for the full data set and pre-register replication before we say something. This is more a proof of concept to me. Okay. We're also looking at kinematics. So we're very interested in how the body reacts to this. So for instance, in color saturation, you can see this is the reaching movement that people make with their hand. You can see that across all levels of color saturation, we get a very typical movement, right? Baseline and all this, so people send their hand out and the velocity. However, when we muck around with time, we can already start to see a very interesting effect that the baseline is over here, but across other levels, the movement of your hand is different. Okay, so people are moving their hand differently, and this is probably impacted by something strange happening in their sense of time in their environment. We're really hopeful that through the kind of the kinematics, like we can now see in the sense of agency, we can pull some kind of implicit measure of what's going on without just, so we can back up what people are explicitly saying, if it's real or unreal, with like data coming from their movements and their eye movements, which I'm not going to show here, and the pupillometry, to see what's happening within their mind by reading out their neurophysiological data. We're also looking at the heart rate. We know that heart rates are very sensitive to surprise, well, not very sensitive, they're sensitive to emotional states. So surprise, I love it. Whereas the Queen of Hearts here is bullying Alice, to no effect. And we can see that within each trial, we have a very clear shape of a heart rate. So it kind of drops and then goes up. We do not know yet to pull out differences between this, but just to say we're looking into how the body and the heart relates to this. Very interestingly, there's recently been some work showing that if you look at heart rate, you can estimate the strength of the psychedelic experience. So the entropy of the heart rate variance is linked linearly to the strength of the psychedelic experience. So maybe there's something there between how our body reacts to how strange something feels. Okay. We're also starting now doing some fMRI on this, going to use both kind of normal parametric stuff. It's difficult to transverse these into fMRI without losing some of the realism of virtual reality and the movement, but the imaging is kind of like that. We have some very preliminary data showing that for a few of these, we have a region in the medial frontal lobe that has shown a difference no matter which manipulation you do, okay, it changes. So you kind of think that across different types of manipulations, they're probably encoded at different low-level regions. So shrink, right, has not so much to do with the visual cortex compared to like this granulation or something. It's probably encoded in a more high-level region. So we're kind of thinking, is there maybe a frontal region which is kind of looking back and trying to flag these strange events across different types of variation? Interestingly, this also sits very well with regions known to be related to reality monitoring. John Simmons has very interesting work showing that this sulcus here, the pre-cingulate sulcus here, the length of it relates to people's tendencies to changes in reality monitoring and schizophrenia. So there is some evidence linking this frontal, maybe metacognitive region to looking back and trying to assess what kind of experiences we're having. Okay. We're also leaning towards MEG. We now have a brand new OPM MEG here, which allows some movement. So we're hoping this will allow us to kind of retain some of the ecological naturalism of this task while also doing good imaging. Okay. So just as an overview of the whole project, I talked mostly about this modeling of reality, and we're doing trying to get to real Bayesian modeling here on this. And work package 2 is about the brain and reality. And the third one is what we call altered reality. And here we are going to work with schizophrenia patients and see if their priors are shifted compared to neurotypical people. The idea is that if you've had really strange experiences in your life before, maybe all this kind of these small things within virtual reality would not impact you as much as they would impact a neurotypical individual who has not had these special experiences. So in a way, what we're expecting is them to have wider priors regarding what reality can contain because they've experienced different things. We're also looking at a pharmacological manipulation using ketamine, which is known to impact reality monitoring and it causes depersonalization, while not being a very strong hallucinogenic. And we're also now looking and see if maybe we can actually do this also with psilocybin, which is clearly a psychedelic and causes exactly these kinds of strange things. Okay. How am I for time? Do we have another 5 minutes?
Yeah, definitely. You can stop, you can take 10 more.
Okay, no, so if I have 5 minutes, I just want to talk a little bit about Wonderland. So this is work funded by the Charles Rosen Foundation. And the idea here is that when we were thinking about this, we said, well, everyone asked, what about kids, right? So clearly, when you're 6 years old, it's really fine to have an imaginary friend. But at 16, if you have an imaginary friend, that's worrisome as far as mental health, right? So there's something that happens between younger ages and older ages where the sense of reality seems to become more clear, more strong. This is probably within our model through gaining more knowledge about the world, okay? And at the same time, it seems that like imagination and imagery, which I at least remember that I used to have a great imagination when I was a kid, and you can see kids taking a piece of chocolate and saying, okay, this is a spaceship and playing around with that, also seems to go down. So in this project, we are curious of seeing how the sense of reality relates to imagery and to mental health and well-being. And we're doing both a cross-sectional and longitudinal study. So we're taking 2 ages in which it's known that the sense of imagination seems to decrease. And we're testing both imagination and sense of reality and seeing what kind of mental health and well-being outcomes they have. And so right now we're taking 7, 8-year-olds and 11, 12-year-olds, and they're doing basically a kind of simpler version of the same task. So they do JNDs, and I was super worried about, can you get psychophysics in kids? I was not clear about 7-year-olds in psychophysics. And then they do the same reality rating task, and we have a clinical assessment for each of these. And we have 2 fantastic subjects, because they're my own children, who happen to be the same age. So first of all, I'm happy to say that we get pretty good psychophysics in kids. I mean, they can get this idea of same different after we explain what that means very well, what Zehe means. And of course, I'm not going to speak anything about this. We can see that there are differences in the way they rate reality as well. But this is really a proof of concept. I think it's a very, very interesting project to see how does this happen and what should happen. Okay? So just to kind of summarize this talk, we provide an empirical approach to study the sense of reality using these virtual hallucinations. We can discuss whether that's a good way or a bad way to do it, but it's the way we're going, and I think it's a fair way to do it. It allows us a lot of empirical precision. And these psychophysical and subjective measures of sense of reality are probably very relevant. We're already seeing they're probably very relevant to understand psychiatric conditions. And the next goals for us are kind of really latching on to both the developmental aspect and what are the neural mechanisms standing behind the sense of reality. And this is what we're going to be doing in the next year or so. Okay. So before I take questions, I just have something very important to say. And I think it's really important to remember that all this reality is just an illusion, right? It's a persistent one. It really helps us get to our cars and get to work and go home. But if we retain some idea that this is all just a representation, then it allows us a little bit to escape this tyranny of reality, of being stuck in there's just one way of perceiving the world. I think we can personally and also as a society gain a lot by relaxing a little bit our how we portray and feel reality, and maybe accepting that different people have different realities somewhat. And maybe that's okay that we don't experience everything in exactly the same way, and there's room for little variability and variety here. Maybe it's even a very good thing. Yeah, so I want to thank this team, especially Gadi, Dori, Paz, and Oded. Most of the work here has been their very hard work over the past 2 years. This project is funded by an ERC and Charles Roven Foundation for the Wonderland project, headed by Neva Goldberg. And yeah, thanks to all of you for listening, Prof. And if someone is interested in these things, we are still hiring, especially if you know computational modeling. We'd love to have you. Okay, thank you, everyone.
Thank you very much, Roy. I'm inviting everybody to unmute yourself, and let's give Roy a big applause for a wonderful and inspiring talk. And I myself also have a few questions and suggestions, but I'm opening the stage for questions, and but I'm happy to go if there's Rafi,
Well, I have a
also
question.
sense your, yeah, I could sense your go on.
You can trust Rafi for a question.
Yeah.
Well, great program, Roy. Very interesting, and let's hope it will be very significant. It's already promising. I have one. I really like the slowing down and making things fast aspect. And one thing I wonder is whether you already see some signs of adaptation. In other words, if I sit in such a world for half a day, will I, at first it will appear that everything is slow, but will I gradually get used to it? And then of course, will I behave in a compatible manner?
An excellent question. I hate adaptation. So yeah, adaptation, we've seen this mainly within the psychophysics. So psychophysics turns out, like I always thought psychophysics was like physics. It's more like a psycho, right? So people, you can see a lot of these adaptations within that. What we've done within the paradigm itself is that we put in many like baseline trials, a lot of baseline trials, right? And then we also have some breaks which people, so they kind of stop and they just get the environment again to really re-experience it as a stable and non-volatile environment. Okay?
But still, do they adapt or not? I mean, I know, regardless if you like it or not,
first of all,
the way you describe it, it seems that there is a good chance they'll adapt.
So I hope not. We haven't checked this yet. When we initially checked this on the original data set, we saw no difference between the first block and the last block. You have to remember that all this is intermixed. It's not blocked, right? So you get one like this, one like this, one like this of 5 different levels with about 30% zero like normal, okay? So yeah, you have many things to adapt to, right? So it's not like the same stimuli which is continuously portrayed over just one alteration, okay? But it's an excellent question. We'll have to look at that. I think it's an interesting aspect here. Can we adapt to this new reality and how?
Thanks.
Thank you, Steve. Happy to see you.
Hi, great to see everyone. Thanks for letting us gate crash from Twitter.
Great.
Super cool talk. Thanks for outlining this. It's a great program of research. Very exciting. So my main question was about, in your JND experiments, you could reframe those or think of those conceptually as judgments about perceptual attributes. And I'm just wondering how you distinguish between something that's just like about the external world, like a change in some feature, and a judgment about reality or perception versus unreality.
Yeah, I think that's a good and fair question. So when they start off with JND, they don't know that we're going to ask anything about reality, right? So basically, we're asking them, okay, you see these two experiences, because they're not images, right? They do something. Were they the same or not? Okay, and we kind of, they know. We show them first of all a very a clear exemplar, so they know what to look for. At the beginning, I didn't want that, but then, people were not sure what they're looking for among these 13 different alterations that we originally had. So they're making this very clear judgment, okay, between these two things. And after that, we're asking them, well, how do you feel about this? Is it strange to you or is it normal to you? So it's fair enough, maybe, and we're kind of seeing this in these preliminary results, some things, when you notice them, they're weird. So if you get this ripple effect, if you notice it, it's weird, okay? I mean, maybe they're just reading off that cue. That's fine. So if you notice it, okay? But if we can see responses, either neurophysiological or even behavioral responses to the more subliminal or liminal levels, this to me indicates that they are probably not really tapping into a direct comparison saying, okay, they know that we're looking for this. And often, you have to remember that most levels are below the threshold, right? So most of this experiment, you're actually getting things which are below your perceptual thresholds. And you're asked, okay, how realistic is this? And people are not actually sure what they saw. So the examples I gave here are very high levels. What happens if there's kind of something strange, you're not sure what it is? And how does that impact your sense in a very phenomenological and subjective way? And not just this clear delineation, well, was there something not normal?
Cool, that makes sense. Thanks. Can I ask a quick follow-up? Is that?
Yeah, sure.
I was intrigued, what's going on with that negative CAPS regression? Is that you had a blue bar that was going negative?
Let me see. That was from our previous paper from 2020, so I have to look that back up.
Yeah, the perception.
Yeah, so the correlation, it was a negative correlation with the CAPS. Yeah. I don't think it was significant.
Okay.
So we're not making a big deal out of it. Yeah.
Okay.
Yeah, it was not significant. I remember now. Yeah.
Cool.
Also, on taking this, that was not so many subjects. Yeah.
Okay.
So we have to be careful with this.
All right. Thanks for the talk.
Thanks, Dave.
I also have I have a few questions, but I'll start with the direction of change or the variation from reality. You can, for example, if you think about time, you can make things go faster and you can make things go slower. And just by my, sense of, my intuition, things that go slower are more, I would have more of sense of it being not real than when things are played fast. For example, I can hear, and I'm thinking also about audio, and I know that you haven't tried it, but I'm thinking maybe that's another thing to check in the sound, voices and stuff like that, whether things. And I'm wondering if there's if this is more or less symmetrical, like there's a range, and once you get out of this range, you have the same sensitivity to it being unreal, or whether there's some bias towards like faster being more and slower being less, and the other way around.
Yeah. So first of all, that's a great question. Some of this is eaten up. So there is some overlap between our perceptual discriminations and, okay, so if seeing something faster is, for instance, more noticeable, because it's more salient, we're going to factor that out through using the same perceptual threshold, right? So because we're kind of checking how noticeable or some salient, and we're controlling for that. So some of this is probably already eaten up by that. The one place where we do have an hypothesis is that from our model would say that if you become smaller, yeah, or shorter, right? This happens to us much more. We sit down, we stand up, we lie down. We have much more experience with becoming smaller than becoming kind of old-Siperi, you know, huge, big, very tall person, or hey. So
or crawling on the floor.
Or crawling on the floor. In that sense, we should have a wider prior for becoming smaller than becoming taller, and it should affect us less. That's an hypothesis we have. We're not seeing it in the data yet, but we're, yeah.
Okay,
so it's something that should be asymmetrical.
Okay, great. Another thing I want to relate to is Rafi's suggestion about the adaptation. I actually think that you may find, if you don't do it blocked, that people will adapt. I mean, I'm thinking of playing YouTube videos and not music and stuff, but you know, things I want to hear. I start by going a bit faster, and then after a while I can go even more faster when I adjust to the faster level, so I can go. I can't do it at once, and I'm thinking maybe if you, it may be interesting to see if you moderately or continuously change the threshold versus doing it at once, whether you would see differences in sensitivity or in, you know, metacognitive or in judgments, or, you know, in how people are confidence rating. If you do it moderately or you do an abrupt change at once, even if the final amplitude is the same from the standard, let's say. And another thing about the kids, the Wonderland project, which is really exciting. So there's also an aspect of perception where kids have more veridical perception. They don't use contextual cues. So for example, many kids at the age of 5 or 6, which is below the age that you're planning to be testing, but they don't see Kanitsa triangles. I think Kanitsa starts at like 6 or something like that. So they don't have all these completion and contextual effects. And I'm thinking that maybe this allows us to get, you know, the contextual filling in that we make as adults. Maybe these are the ones that contribute to our sense of reality, and kids don't have that, so they have to develop their own contextual ideas, and they can and I'm just
I think that's exactly the logic we're using. In a way, what you're saying is that, and the same thing has been said for psychotic individuals, that they have a weak prior. So children have a weak prior, and maybe these weak priors, because they don't know so much about the world, is causing them not to experience these kind of malfunctions, such as illusions. Okay, I think what's really, I always use this example. So you have the visual cliff, right? So children to a certain age, they'll crawl over an elevated glass floor without being afraid of falling, because they have no idea about this dimension of falling down. And then kind of as soon as they start trying to get up and they learn about this whole idea of gravity and height, all of a sudden they become apprehensive about approaching this. So this is learning about the structure of the world. And learning about the structure of the world is what allows us these predictions. And what we're doing is actually, by creating situations in which we contradict these very basic things, we can actually test. And I think the beauty of it is, what is this model of the world? What is the model of reality that we learn? How similar it is between subjects, how similar it is to what happens in psychiatric conditions, okay? The inverse of our results is a model of reality that we've learned from interacting with this world.
Interesting. And I wonder about the adaptation aspect that Rafi asked about. When you said you had these experiences when you were in a mental hospital, you were visiting or something like that. Not when you were visiting there as a scientist. So I'm wondering if at the end of the day you felt there's some sort of adaptation or synchronization. I mean, it sounds like you had some synchronization with the patients to some extent after a day of, you know, experience in where maybe the real world was left out, and you were diving into their experiences at some point.
I wouldn't say it's adaptation. I'd say it's more kind of metacognitive doubt, right? So all this is also questioned by a very high level metacognitive system saying, well, what's going on? This is kind of the explicit aspect at the high level of the, so, you know, same thing if you and me would meet here and you'd say, well, don't you see that? I'd also start doubting maybe, you know, we use this consensus to see what's going on. Because it turns out, I think, that we're not that sure about what we really experience, right? You know, if I experience something, you're experiencing something completely different, that would be worrisome for us. Like one of us would have to be wrong, right?
Yes.
And yeah, so I wouldn't say it's adaptation. I'd say it's more a kind of a high-level metacognitive rethinking of all this. Psychedelics also do that quite a bit, huh? So having a very, very different experience. But I think also travel does that. If you go to India and you walk out into the main bazaar, you're going to have to reform all your priors, many priors about having a cow in a store, reform, right? So you have to make a very, very quick reformation of many of these aspects of how you view the world. And I mean, that's a good and interesting thing. We actually enjoy that.
Lovely. Madis?
Yes, hello. Greetings from Tartu, Estonia. I was wondering on these results, you had this one aspect of modifying heaviness or lightness. So how did you do that? Because in VR, you're just holding this same weight controller all the time.
Sure. So we didn't do a heaviness. I think that's kind of mislabeled. We have a lot of discussions of what we're actually doing, because some of these are actually impossible things, and I'll give an example in a second. This is a gravity. So what we call heaviness is either increased gravity or decreased gravity. And we do that. Actually, that's quite nice, because when you work inside virtual reality, there's actually a gravity engine, and you can just dial that up. So it's a very nice thing. It, of course, does not impact the real weight of your hand or the controller or your body, which it should. So there's always an imperfect, we're not doing haptics here, we're not doing auditory. I can tell you we had a super interesting discussion over many months now. How would a butterfly look flying at low or high gravity? Okay. So it turns out they actually did this in space, but the video is too short to answer our question. So we actually had to play around until we get a feeling of what it's like, because no one knows what a butterfly would do in a high gravity. And yeah, so it's one of these questions that when you start playing with things that are unreal, you have to answer through intuition or a feeling. That being said, in movies, we do this all the time, right? In movies, they show us impossible or unreal stuff. And if they do it convincingly, you say, wow, that's no gravity. That's a bird flying upside down. Okay?
So I also have a question.
Yeah, Tilka.
First, great talk and great project, and very courageous one, like touching upon the sense of reality. I have a headache from thinking about it during this hour. So how do you manage great project? Or ketamine. So I'm still kind of stuck about Rafi's very insightful comment about metacognition and trying to understand what is it, the sense of reality. And I don't think it's a thought, right? It is kind of hunch or feeling. And in this field of metacognitive creatures, I think the sense of how sure am I in my correct answer, right? This very prominent representative of metacognition is maybe feels somehow related to this sense of how real is it? How am I right about this? Yeah, how real is it? It's a bit like metacognition or certainty about the world rather than about myself. And I'm just really wondering about these individual differences, and are these two forms of metacognition related to each other? This is like the first question that I had, and then another one, again, from trying to understand what kind of process is this? Is it cognitive? Is it embodied? Is it holistic? Is it what? I'm trying to think how you can affect the thresholds of reality with prior beliefs. For example, you mentioned the psychedelic experiments of yours, like giving people substances. What will happen if you tell them that you give them substances, but you actually give them water?
That's a nice idea.
Induce a belief that they are under influence, and then how fastly will they be willing to change their sense of reality? Or mood, another option.
A great question, really touches on stuff we don't mostly have an answer to, but I can give you my 2 cents. So I think, as I said, it's kind of a continuous process. It starts out for very low level stuff that we don't feel. So at the beginning, the brain is kind of fitting everything to fit what it wants to fit in a kind of Bayesian way, okay? If stuff gets too weird or too high level, because some of these inconsistencies, they're not unimodal. I move my hand and my hand has a delay on it, which is kind of what I worked on, the sense of agency. And this is one of our you have to do volitional sensory motor integration to know that there's a problem. It's no longer just a visual problem, right? So it's already an integration problem. And I think at the low levels, you just fix that without knowing it. And at a high level, it also becomes explicit. It becomes a thought. Some people say, you know, something's wrong here. You feel something's wrong here. And I think we have this with a lot of our very basic fundamental processes that relate to the self. We have the same thing for the sense of agency, right? Sense of agency, we don't usually notice it until we have a non-volitional movement, okay? Until something's wrong with our sense of agency, we don't even think about this thing, okay? It's the same thing with consciousness. Consciousness is something we don't think about unless we get something strange and weird, which kind of demarks what this is. So I think for these kind of transparent processes that our mind and brain do for us, we only feel when something goes wrong. And the brain is really trying to kind of solve these problems for us. Because I think what's actually coming onto our senses is super noisy, super strange and noisy. And the brain is making this an orderly experience. And when it gets too bad, too disorganized, well, what's going on here? That being said, if you're drunk, you know to expect strange things to happen, right? If you take an LSD, if you don't know and you get this experience, but you haven't taken LSD, then you'd be much more worried, right? So having a context to explain this, even the context of VR. If people woke up in the morning and they experienced this, they would be going to a hospital, right? Okay, it's an experiment, it's VR. Same thing when we go into a movie. We even enjoy being chased by a maniac with an axe. We wouldn't like this in the real life, right? We pay for this in a movie. In real life, we would not want this. Okay, so the context is very important. It allows us to kind of give different precision to priors and, you know, but Rafi thinks we live in a simulation anyway, so I guess it's all kind of that.
And it's free, you don't have to pay for it.
Exactly. Great.
Ro'i, so this was a fascinating talk, very inspiring and mind challenging, I would say. Was this a real talk or not? So I'd like to thank you a lot for this amazing talk and asking everybody, you can unmute yourself and let's give again a big applaud to Ro'i.
Thank you.
Wonderful talk, Roy.
Yes, wonderful.
Thank you.
And I just want to say next week we have Nico Krigiskorte at the same time talking about controversial stimuli, optimizing experiments to adjudicate among computational hypotheses. So you're all welcome to join. We'll send the information. And Ro'i, thanks again for joining us. It was lovely having you.
Thank you for inviting me. If anyone has questions, you can contact me. I'm happy to continue this discussion.
Lovely. I'll
Bye,
contact
everyone.
you.
Thank you very much.
Bye.
Bye. Thank you.
Bye-bye.